All right, today's lecture is all about severe weather, so we're going to talk about what happens when weather goes wrong. So far, we've studied a lot of the processes that actually cause our weather that we see, but we haven't looked in general at specific weather events. That's today. And we're going to, again, talk about what happens when it goes wrong. So, for the bell ringer, in your bell ringer section, or just somewhere on your notes today, why don't you write down your experience with severe weather? So maybe it's a thunderstorm that you were in that scared you when you were little, or I have a friend whose house was actually taken up by a tornado when she was in it. Or it could be your experience with any of the recent hurricanes that we've had. I just want you to share just a little bit about your experience with severe weather, no matter what the weather event was. Or it could be blizzard. I don't know. If some of you are from up north, you can talk about what it was like to be trapped in a blizzard. Up to you, but just put that somewhere on your notes today, maybe at the bottom of the page. When you're ready, unpause the video. Alright, so just a review, which is good because some of you have not been doing your notes like you should. A reminder, those notes are for credit and they are due the day they were assigned. You have 14 days before those lock and you are not able to do them again, meaning that the 0 that is there is the grade that you have earned. Here again, though, is review from the other day. So we talked about 4 different air masses that we have. They depend on where they are, where they formed, both over land or sea, and how close to the poles or the equator they were. Remember, when we say continental, that means that the air mass formed over a land, generally a continent. When we say maritime, we learned that that air mass formed over the ocean or the sea. We learned that when an air mass forms over the land, it will bring dry air with it. And in contrast, when an air mass forms over the sea, it will bring wet air. We also learned that where latitude-wise the air mass forms will depend on what temperature is brought about by the air mass. If the air mass formed near the poles, then it will bring cold air, and we call this a polar air mass. And if the air mass formed near the equator, it will bring warm air, and we call this a tropical air mass. And we combined the two words, so where it formed, whether land or sea, and where it formed, whether near the poles or the equator, to denote what kind of air mass we have. That means that we have 4 air masses. The very first one we learned about was a continental polar air mass. It will bring about cold temperatures, and there will be little moisture or dry air. In contrast, if we have a continental tropical air mass, which forms over land in a region close to the equator, we will have very hot temperatures brought about with that air mass, as well as very dry air. Our other air masses that we have are called maritime. This means that they formed over the sea. They will bring about moist air, and if that air mass is formed over the sea near the equator, it will bring warm temperatures with it. And then if that air mass is formed over the sea near the poles, it will bring cold temperatures with it. And again, those air masses will be moist or humid. Again, our definition of air mass, this is all review, is a region with similar temperatures, humidity, and pressure. Moving on to our second bit of review here. This is just to test your knowledge. We've done this before, so I will skip through it. We have 4 types of fronts, and fronts are what occurs when air masses hit each other or come in contact with one another. We call our warm front a warm front because the warm air mass is the one that is moving. The warm air mass will run into a stationary cold air mass and go up and over that cold air. During a warm air or a warm front, we will see light rain, nothing violent, just a light rain, and it'll generally bring about warm temperatures. In contrast, our cold front is going to happen when a cold air mass runs into a stationary warm air mass. That cold air mass and the force of the movement will go underneath the warm air mass, pushing that up and over the cold air mass. Cold air masses will generally bring about very violent storms and cold weather afterwards. Now we said our stationary front is where both of the air masses, the warm and cold, are moving, and they both run into each other. But the problem is that neither air mass has the force needed to push the other air mass out of the way. That is why it's called stationary. Generally, those air masses are not moving, and they'll stick around for a long time. Eventually, one of the air masses will gain the force to either go over it if it's a warm air mass or under it if it's a cold air mass. When it does, the weather associated with either the cold front or the warm front will happen. So the weather that happens at a stationary front is dependent on which of those air masses moves. And then our last one is called an occluded front. This is where a cold air mass runs up onto a warm air mass, or two cold air masses squeeze a warm air mass in between them. As far as weather is concerned, it will generally bring about a cold front, meaning that there will be violent storms afterwards. Again, don't forget that a front is a boundary between air masses. So what happens when two air masses meet? We call that a front. Just to review, which of these from the symbols on the bottom of the slide here, and this is supposed to be blue, this triangle right here, I don't know why it's looking a little purple on my screen. Which of these brings about heavy rains and storms? We should know, we should learn by now that the cold air mass will bring about heavy rains or storms. And then which of these results because neither air mass has enough force to move the other? We should identify that as a stationary front. Now we've got some definitions to take care of before we can talk about severe weather. The very first definition is lightning. This is the natural electric discharge between clouds and the ground. I have the picture in the background of what lightning might look like. Hopefully, you've all seen lightning from a distance. The next definition we need to take care of is thunderstorms. These are rain-bearing clouds plus lightning and thunder. That's why they're called a thunderstorm. They can last for a long time, they can last for a short amount of time, and they're generally as a result of a cumulonimbus, or they generally come from cumulonimbus clouds. Our next definition is the hurricane. Hurricanes are storms that form over tropical waters. They are typically associated with very violent wind and heavy rains. Here's an example of a satellite picture of a hurricane forming on the Earth's surface. They're spiraled in shape. We've had several of them in your lifetime with varying effects or varying strengths. Next example is a tornado, or definition. This is a vortex of violently rotating winds, and generally they're funnel shaped. One predictor of a tornado is the funnel cloud formation, or that swirling of the clouds. Not as huge. A hurricane, in contrast, takes over a large area. A tornado is very small compared to the hurricane. A probe. So this is a probe. It measures the tornado's wind speed and direction, temperature, and humidity. They can look something like this, which is stationary on top of a building, or they can look like something like this, which is actually put in the path of the tornado itself. Inside there, it's got a protective measure around it, but inside there it's got readings that will read things like wind direction, wind speed, travel of the tornado, all that good stuff. And we have a couple more definitions. We've got the eye, so this is the focus or the center of a hurricane. The rest of the storm will rotate around the eye. We've got a very nice picture here of the eye wall of the storm, which is that clouds. Generally, the eye of the storm will be very peaceful. And if the eye of the storm passes over you, that can indicate that about half of the storm is past you already, but that means you have half to go. And generally, that storm will slow down as it passes over you. Rain bands is our final definition. Rain bands are areas of rainfall significantly elongated. Typically, we are talking about these in terms of a hurricane. This hurricane radar simulation that you're seeing on the screen is from NOAA, the National Oceanic and Atmospheric Association. They do a lot of things to do with the atmosphere and the ocean, but one of the most notable things in our lives that they do is they track hurricanes. This hurricane that you're seeing going up the coast of North Carolina happened in 1989. This is Hurricane Bonnie, as it wrecks the coast of North Carolina. Not as dangerous as Fran, but still caused some havoc, and it sat over Morehead City for quite a long time. You can see that as the hurricane moves from where it started, which it'll start over in just a second, to where it ends, it dissipates, meaning that the storm lessens right here. As it's still, majority of it is over the ocean, it is much stronger than as it moves or makes its way across the land. That's because we'll learn in a second that a hurricane gets its power from the ocean itself. If it's not fed by that warm air and moisture, then the hurricane will not happen, or will be a lot less strong. So as it makes its way over land, generally hurricanes will dissipate and decrease in strength. We're going to compare and contrast tornadoes and hurricanes for a second, because they are very similar weather events, but they form quite differently, and there are a lot of differences, honestly. So with this event diagram, so one side is hurricanes, one side is tornadoes. The middle is indicating anything that they both share. In this case, both hurricanes and tornadoes both share strong rotating winds. So you can see that, we saw that on the pictures and the diagrams and the radars, that both of them are rotating cloud masses. A hurricane, though, has got to occur or form over water, and it forms for a long time. So generally, because of the radar, we know, and the weather advances and technology advances, we know when a hurricane is coming. We can see it, we can prepare for it, we take measures to protect ourselves and our properties. But it takes a while to form. It's gathering power and pretty much charging as it moves along over the ocean. Hurricanes are generally long-lived. Sometimes they can sit for days, like we saw with Florence, over the land. And they travel a large distance. So not only did Florence hurt us and Wilmington, it hurt Morehead City and all the way up into the Outer Banks as well. Tornadoes, in contrast, they occur over land. Now, a hurricane starts on the water and moves towards land, but it slowly loses its power as it goes over land, because it doesn't have that warm air and the moisture. In contrast, though, a tornado will form over land. It'll form spontaneously, and for the most part, they're short-lived, and they travel a much shorter distance than a hurricane. There are three main parts of the hurricane. The eye, which we talked about in our definition, or the very middle of the hurricane, which is depicted right here by this purple dashed line. Please draw this, by the way, or you can't draw it. If you have it already, please draw it. If you do not, we'll find a picture and we'll show it to you. The eye wall is the clouds or the cloud mass around the eye. And the rain bands are those varying, and they're due to the high and low pressure around the storm. But they are the bands of rain that rotate around the eye. Good. And again, they come in the band shape because we have several low pressure systems. As you can see, each rain band is a low pressure system that brings the warm, moist water from the surface of the ocean up into the cloud or to the atmosphere, making it that much more dangerous. We will pick back up with our last bit of the lecture in a moment, or in another video.